Good morning, pre-cal students. I'm sorry I didn't get this video out yesterday. I had to take care of Calvin and he was a little sick. Anyway, the lesson from yesterday is over hyperbola. Hyperbola are really useful for mathematicians when things are equal distances apart. They're great at estimating how light will reflect, great at estimating distances. Anyway, you'll notice hyperbolas have the following shape. They're pretty much the exact opposite of an ellipse. Whereas in an ellipse, it opens inward toward each other, hyperbolas open outwards. Just like ellipses, hyperbolas can either be oriented on the x or the y-axis. They can also be oriented at oblique angles, but we're not going to worry about that for now. We're just going to consider the basic situations of a hyperbola where they're centered around the origin and on the x and y-axis. Anyway, the formula for hyperbola is very similar to the formula for an ellipse. However, you'll notice instead of a plus, we have a minus here. In addition, you'll notice the a squared is always first, okay? Remember, a is our term that's going to have the highest value, and it will always be first. The a term will always be the vertex or the intercept of your hyperbola. That's this point right here, or right here, right here, or right here, okay? So, hyperbolas are unique because they have oblique asymptotes. So you can see the dotted lines here and the dotted lines here. Your asymptotes can help you draw the hyperbola as well as drawing this auxiliary rectangle that you see on page 703. The auxiliary rectangle, you just make a square with A and B, where your points are A, B, B, negative A, and all that stuff. Anyway, hyperbolas have the following properties. The foci and center are outside the graph, whereas for the ellipse, they were both in. In addition, the center is still the midpoint between the two foci labeled C here. We still use our equation we learned in 11.1 to find the foci. C is equal to the square root of A squared plus B squared. And also, just like in last section, please always make sure the constant, usually on the right side of the equation, is equal to 1. If it's not equal to 1, just divide it to make it equal 1. No big deal, okay? So, I went ahead and did a couple of the example problems to help you with your homework. I feel like the first 6 are the most challenging, where you have to derive the equation. So, in number 2, we're given intercepts. Remember, the intercepts and vertices of the hyperbola are the same. We're given that they're a y-intercept, so that means we're going to be using the one where y is first. A is our intercept. We then use and we're given the equation for one of the asymptotes. You'll notice for the hyperbola, we have the asymptotes are different for when it's oriented on the x and the y axes. So just use your book or memorize them, whatever you need to do. Just know that one is positive, one is negative, and they switch from b over a to a over b. The case where y is first, it's a over b. So we're given our a is 12. We can use this a over b in order to set up a proportion where we get 3 over 2, which is our a over b, and that'll be equal to our a 12 over b. Then we solve our proportion and we get b is 8. Then we square our a and b and we have our equation. Number 6 is very similar, except we're given the foci. Remember, the foci we're given the vertex. Remember, the vertex and the intercept are the same when it's oriented on the axis, which we can see it is because we have a value of 0 for the x. So we're given our a and we're also given our focus. We remember the focus is C, so we use this equation, plug our values in, solve for b, square our a and b, and we get our equation. Fairly simple stuff, but I wanted you guys to see how I went through it, okay? So just a couple other things in this section. Remember to make the constant equal to 1 by dividing by whatever you need to. And remember that ellipses, what we learned about last time, will have a plus instead of the minus. You'll need that for some of the matching problems between 7 and 12. There are a couple word problems. I want you guys to try that on your own. It's a bit of a challenge. Look at example 4 in the book. That's on page 705 and 706. Good luck. We'll talk about them in our Zoom meeting today. And I hope you get to see this video. Talk to you later.